We're going to start chapter 11 out of order. It's going to be out of sync. It's okay. But the ordering of the sections is going to be crucial for us because we want to do things in the right direction. And you'll know what I mean once we get this chapter done. So, 11.6 talks about, this is on page 694, it talks about conic sections. Those are parabolas, hyperbolas, circles, and ellipses. We start off with parabolas, something we're used to. And they have a few things they're asking for. So, and number 9 through 16 gives the equation of parabola. For each parabola, find the focus directrix, sketch a graph, including the focus and directrix on your sketch. I'm going to ignore that part for now. I just want to make sure that we are solid clear that we know how to graph y equal x squared over 6. I don't know how you were taught this back in the days, but I know this is centered at the origin. And if x equal 1, y would be 1 over 6. And if x equal negative 1, y would be 1 over 6. This is a very wide parabola. That's all I need. So for now, I'm not going to really worry about this focus and directrix. I'm just going to say in this parabola, the center is at 0, 0. Not the center, I'm sorry. The vertex is at 0, 0. They want me to label this thing called focus, and they want me to label what's known as the directrix. I'll tell you what that means in a minute. I'm going to go to number 14 and do the same thing. And say, well, okay, this is a parabola. It's opening downwards. It is centered at the origin. And if I move 1 to the right, I am at negative 8, right? So let's say that is 2, 4, 6, 8. This is a very steep parabola. Now, I just want rough sketches. You really don't have to label much, except for I do need the vertex labeled clearly. I need the focus coordinates labeled clearly and the directrix. I didn't tell you what that is yet. I'll tell you what that is in a minute. Now, if I look at x equaling to y squared, we switched rows here. That is, instead of y equal to x squared, x equal to y squared. So, I could, if I'm really confused on that, I could say, you know what, let me look at y equal to x squared. How would that look? 0, 0, 1, 2, negative 1, 2, and switch the rows and columns. You know, basically, switch the x and the y, and this is 1, 2, so 2, 1, and this is negative 1, 2, so 2, negative 1, and I can get a very good idea of what that graph looks like, just like that. The vertex, I know it is at 0, 0. They still want me to label this foci thing, and they want me to find the equation for the directrix. Again, I'll get that in a minute. And as for this last piece, I didn't give it a grid. Let me give it a grid. Here we go. The grid will be provided on the test. You just have to worry about the graph. So if I look at this, and again, if I'm comfortable with this, that's fine. If not, I'm supposed to say x equal negative y squared over 2. If I'm not really liking this much, I could say, well, let me go on the side and figure out what does y equal negative x squared over 2 look like. 0, 0. 1, negative 2, 1, I'm sorry. 1, negative 1 half, and negative 1, negative 1 half. So 0, 0, switch the x with the y. 1, negative 1 half, that will be negative 1 half 1. And negative 1, negative 1 half, negative 1 half, negative 1. And there's the graph. It's not centered identically. That's why it doesn't look symmetric. And that's how the graph looks like. It's a sideways parabola. It's open toward the negative axis. Alright? Now, that we got this down, y equal 1 over 4p x squared is a parabola opening up or down, we're not sure, depending on whether P is positive. So if this parabola opens up, you take this P, you move that many units from the vertex, that is the focus, and you move that many units in the opposite direction, and that is the directrix. So the directrix is a line. And that's the only definition we have. So, how am I going to figure this out? I'm going to take the quantity in front of x squared, which is a. I'm going to take the quantity in front of x squared. I'm going to take 1 over 6 and set that equal to 1 over 4p to figure out what this p is. If I cross multiply, 4p equals 6. P is 3/2. And this is how I'm going to remember it. It seems the focus is always embedded within. You know those satellite dishes? And you know that thing in which all the signals will hit if you line it up properly? That's what the focus does. So I know the focus is inside of this, somewhere in there. Well, if I go to the vertex and I move 1.5 unit, that's the focus. That is at 0, 3/2. And if I was to move 1.5 unit down, I kind of squished this. I could fix that easily. And if I move 1.5 unit down and put a line right there, call it L, y equal negative 3/2 because you are below the x-axis. If I go to number 14, apply the same idea. Again, I'm going to take whatever this quantity is, which is the number in front of the squared, the a, y equal ax squared. I'm going to take the negative 8, whatever that is, set it equal to 1 over 4p, and there it is. If I cross multiply, negative 32p equal 1. P is negative 1 over 32. Now what? Well, I know that if I move down, and here I only put the focus, that's it. Doesn't that indicate in this case that my focus is at 0, negative 1 over 32? And I go up negative 1 over 32 and put a line, call it L, and the equation for the line on the side is y equal, if you go above the x-axis, isn't that positive? And there it is. And that's how we do those. Now, let's look at those two. If I take, and I'm going to do the same here, I'm going to give this a bit of room by shifting a bit to the right. There we go. Now, here I'm going to do things, but it's slightly different because the number is in front of the y. Well, what difference does it make? As far as what we need, we are going to take 1 over 4p and set it equal to the number in front of the square term. And if I cross multiply, that indicates that 8p equal 1. So p is 1 over 8. Well, wouldn't you want to go 1 over 8 if this is 1? Of course, I'm exaggerating those. That's the focus. And 1 over 8 to the left, draw the line. Wouldn't, in this case, the focus be 1 over 8, 0? And this equation for the line, isn't that x equal? If I moved 1 over 8 to the left, isn't that negative 1 over 8? And there it is. And as for the last problem, how am I going to do that? Well, nothing changes. I'm going to take 1 over 2 and set it equal to 1 over 4p. I do want to point out, this being negative, if p is negative, that means the graph opens down. Maybe I missed that one here, right? Yeah, it's negative 1 over. The point of negative means the parabola opened down, but we're graphing that first. We don't need that. That's for the average student. We're not average. Look at poly students. So, If I cross multiply, I'll get negative 4p equal to, p is negative 1/2. Again, the only significance of p being negative tells me the graph open up to the left. I already drew that, but if I am at 1/2 a unit, if I move half a unit right there, oh, I forgot to mention here, the vertex is at 0, 0, and the focus is at negative 1/2, 0, and the equation for the line, if we move half a unit to the right, wouldn't that be x equal positive 1/2? And there it is. And that's all you need to know about a parabola, except for completing the square part, which is coming up in the next video. The next on the list would be an ellipse. An equation of an ellipse, well, x squared over a squared plus y squared over b squared equals a 1. That's an equation of an ellipse. You have two squares in which those two are not equal. If they're equal, it's a circle. So an ellipse would stretch out in the x direction 8 units plus or minus, y plus or minus b, and there it is, depending whether a is bigger than b or less than b. And I'll point out few of those. I have to really define few more things, but I'm going to jump to examples first and come back and identify what that is. Okay, I want to start with an example. Since the book starts with awkward examples, I want to pick a straightforward example first and go from there. So if I was looking at how this looks, x squared over a squared plus b, I'm looking at this, y squared over b squared equal 1. Here it says, give 17 to 24, give equation of the ellipse, put each ellipse in standard form, then sketch the ellipse. Include the foci. That's the plural of focus. I'll talk about that in a minute. If I match those, you notice that a squared equal 25. That means what do you square to get 25? So here I am centered at the origin. You square 5, so you stretch in the x direction 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So what do you square to get 25? You square plus or minus 5. And with the same idea, what's underneath y, what do you square to get a 9? 3 or negative 3. Connect those with a smooth curve. And there it is. Actually, graphing is the easy part. Labeling is the hard part. That doesn't look pretty. There we go. Got it. So here the center is at 0, 0. And they want me to label the foci. I'll tell you a bit about the foci in 1 minute. Also, you see the stretch side? Those are called the vertices. They're not asking for those now, but they do later on. And just added information. The stretch side, this length is called the major axis. This smaller one is called the minor, in case you ever needed that. Now, I want to do number 20 before I come back and talk about what the foci is and how to find it. The key in this entire section, whether it's a circle, ellipse, or hyperbola, set that equal to 1. That's not a 1. I can fix that easily. X squared over 2 plus y squared over 4 equal a 1. Now, if I look at this, say, okay, what do you square to get a 4, a 2? This is 1, this is 2, this is 1, this is 2, along that y because it's underneath y. This is not a perfect square. If I was to say, what do you square to get 2? Radical 2. Well, radical 2 is 1 point some. That's okay. If it's not an integer, I suggest you label it. And the graph is right there. And the center here is also 0, 0. And I'll give you really simple how the foci work. Remember, this is called the vertex. Those are the vertices. It's always along the stretch side. Now, the foci is the square root of a squared minus b squared, or the square root of b squared minus a squared. Basically, the larger minus the smaller. So here I'll say the foci are on the square root of 25 minus 9. That's square root of 16. That's 4 units. And guess what? The foci are always on the major axis, the stretched side. So if I go from the center and move 1, 2, 3, 4 to the right, label that. 1, 2, 3, 4 to the left, label that. Wouldn't that be 4, 0, negative 4, 0? I'll wrap this up in the next video.